Hi class, we are going to study today about optimization and modeling part 1. So this is after all the derivatives that you have studied, it comes with the word problems, and we will see real problems here that how we are going to apply calculus. And I break into two parts. So basically you're gonna do whole complete 3 pages with me, and then second part is going to be I'm going to help you half up to the making the function, and then you are going to do derivative part with the textbook, and then there's a last part that you are going to do 2 questions by yourself. So I kind of break into like a game part, level 1, level 2, level 3. So while you go through this one, I hope that you understand the power of the calculus. Okay, so it will be fun. Actually, I really enjoyed this part, and it will be a little bit difficult, but just pay attention to my explanation, and then you can do it. After you do like 10 questions, you may see some patterns. That's what happened to me. So just bear with me and then enjoy it. So farmer has a 2,400 feet of a fencing, and he wants to fence off rectangular field that borders a straight river. He needs no fence along the river. What are the dimensions of the field that has the largest area? Okay, so when you read this question, always I want you to read 2 times or 3 times. That's what I will do. And then first of all, just read briefly, and then just circle all those important information and try to see that what I try to use as an X, and then what I like to get as output. So this is like for me computer programming. So because all the programming will have about 1 or 2 inputs and then outputs, like password and then domain of your email address, like that. So now when you read it, if you don't get it, let's just get the clue what's going on with drawing some figures. So their farmer has 2,400 feet of a fencing. So the total amount that he can use fence length is 2,400, and then he wants to fence around. One side is a river. So here's a river, there's a fish, and there's a boat, and then he like to fence around like this, 3 sides. So no fence along the river, and this total 3 sides of the length is 2,400. Then what they want to get here, so when you see what is the dimension of the field, that the highlight word will be largest area. That's what we like to optimize. When will be the largest area? So when you look at this one, largest area is going to be my output. So that's going to be area. Then input will be what? I like to find the area, then your input had to be one of these sides. So I will set this one as X. So input will be X, length of the side. Then as you see it's a rectangle, this is going to be X as well. And also think about what will be the top then. That will be total. I have a 2,400 as a total length of a fence, but I use a 2x. That top will be 2,400 minus 2x. And now I want to find the area of a rectangle. That will be length times width. So how can I write the function here? So area function of input x will be length times width. In this case will be these 2 numbers. So 2,400 minus 2x times x. That's what I like to optimize, because I want to optimize the area. So that's why I'm multiplying length times width. I'm going to tell you, when you do this one with me, it looks really easy. And when you do it by yourself, you will have a little fun there. So just pay attention together with me. And in here, what is going on? Let me just tell you what's going on in here. First, think about if I have just a total rectangle. And if the 2,400 feet, I can only use one side. So just give yourself example here. I can probably make it 800 and 800 and 800. Does it make total 2,400 feet, right? Then what is the area this time? My area is going to be 6,400 square feet. And this time, let's see that if I can build a triangle width and rectangle with different measurement. Here, if I have a 400, that will be 400, right? Then this is going to be 1,600. So total, when you add it, makes it 2,400 feet. Then what will be the area? Let's multiply this one, and that's going to be, whoa, coincidence. I didn't mean to do this one. Wow, so they actually give you same dimension. Is that correct? Then I'm going to make it a little bit different. So this time let's try with actually 1,000 here. And this will be 1,000. My graph is not that great. And this is going to be 400 and 1,000, 1,002, and then 420, 400 feet. Then what will be my area? I hope I'm not making mistake. Oh, I need more zeros, right? 0, 0, bad math teacher, 0, 0. So here, this is going to be 41, 2, 3, 4. Yeah, sorry about that. And then, so now I will write it, my area carefully. And then 60. So, did you notice that actually I have the same amount of defense length, but you can totally have 400,000 versus 64. That's actually 50% more than this one. Then if you're a farmer, you want to actually do this way or the other way, right? Just for fun, I want to actually go for 600 because I feel that 600 could be our answer just by looking at. So 600, 600, then that's going to be 1,200, 12,000, 1,200, right? Then let's look at, that's a 24. So what do I get now? I get 72, 2, 3, 4 zeros. So this time, if you look at, you see almost twice bigger. That's what we call as optimization. In company, you guys gonna use a lot. Sorry, I got a little bit distracted and explaining pre-cal, but I want to see that why we need to optimize, because although I have the same length of 2,400 feet, but depending on what dimension you set it, you could even put so much more, twice the amount that you can actually put your animal there, right? Because the area is that much bigger. So that's what we like to optimize in this case. What will give me the largest area? Okay, so now I'm not going to explain more details, but I hope that you see the reason why we have to optimize. And now how we're going to find it. That's the equation we actually write it as a programming language, basically, of this whole my observation. So what are they asking here? In order to find largest area, if I put this one out, I know that my function is going to be quadratic function with concave down like this way. So largest means it's gonna happen at the maximum. How do we find maximum? That happens at first derivative. So we are going to take a derivative of area, which is area derivative will give me, this will be easier than using the product rule. So let's do this one. Negative 4x plus 2,400. And let's factor it out by negative 4. And now I get x minus 600. So from here, if I set equal to 0 to find the critical value, I see that x has to be 600. Then we need to check that if this one is a maximum or minimum. So if you graph this one, you will see that 2,400 and then slope is a negative 4. So this coordinate will be 600, right? Your x-intercept is a 600 as it here says. So what does it here say? From critical point, my first derivative, left side is a decreasing and then increasing. Left side is a, first when I look at first derivative, this tell me that my original function is increasing and then after 600 it's going to be decreasing. Therefore, my maximum is happening at 600. So Yana, is this the same question as finding vertex? Yes. So I found my x value as a 600, which we actually found it by plugging numbers, right? So I got 600 as one side. Then what will be the other side? Since we have to find the dimension, that gives me 1,200 feet as a dimension gives us 720,000 feet square as area. Maximum area. Yeah, that's how we solve this one. So this one was appetizer. So now we have a same question. I changed the number, so I wanted to practice it one time and then compare the answer with me. Okay, class, let's look at in-class activity 1 and how did it go. So this one wasn't too bad, right? So I graphed input was the side of the length and the area is the output I want to find. So my function has to be length times width as area. So length times width in here. Then I took the derivative and then what they're saying is what is the largest area. So you have to see the input X output area. Largest area means when I graph it, that represents the maximum value. It has to be the vertex. So with our pre-cal, we can actually graph this one as a 0 and then passing through 1800. If you factor it out by -2, you see that x minus 1800 and times x. So I get 2 x-intercept, and if I graph it by symmetric, I actually see the answer. It has to be 900, right? So I also want to verify with first derivative. When I take the first derivative, I want to find critical point, so I set equal to 0. Then my critical point is going to be 900. So I have to see that what is this value, local maximum or minimum. So I check right here with the first derivative graph. Then here says increasing, decreasing, so 900 has to be local maximum. And therefore I got the prove that that's a maximum, and by plugging 900 by 1800 will give me max area of 1,620,000 feet square. Okay, so that's the answer. Let's continue. Okay, class. So now we're gonna do main dish, and let's look at the question here. So we have a cylindrical can is to be made to hold 1 liter of oil. Find the dimension that will minimize the cost of the metal to manufacture the can. So I want to actually give you some example here. So class, so I tried to quickly prepare what I tried to say. So look at here. I got the 1, 2, and 3 different kind of cups, and I filled up this one with the water, and I want to see that if among those 3 cups, which one will be actually the biggest volume. So let's compare. So I'm going to put this water into next cup, and I didn't fill it completely so that I don't drip it on the ground. And if I put this one, as you see, it's actually same volume. And then if I pour this one to our to-go serving dish, and if I pour in here, as you see, I drip some of them, but also it fits here. Can I say that all these 3 has the same volume? Yes, this one is actually 8 ounces as a 1 cup. So now among those three cups, which one will have the smallest surface? Because if you are the owner of the company, then you want to actually make a biggest container with using the smallest material, right? So this is a question we are going to talk about. We have a 1 liter of oil, and then I'm sorry that I was going to calculate the volume, and then volume is 8 ounces, but I was going to calculate the surface area for you, but I don't think I can do really exact. But among those 3 cases, we saw those 3 cups, and then one of them will give me the minimum surface area, which you want to have smallest surface or material that you're gonna buy, and then you want to maximize the volume. That's what we try to find in here. So all these 3 cases are the same size as 1 liter of oil. Just think about like that. Then depending on the radius, the surface area will change, which we saw earlier example. I explained to you with the farming area. So just think about the example, and then let's try to now see that what we need to figure here. So what will be input? If you cannot find the input, then try to find what is the output. What do you want to maximize? What do you want to optimize? What do you want to minimize? So if you see minimum, maximum, that's optimization. So here it says, I want to minimize the cost of the metal. So output will be cost of the metal. How do we check the price? Price is going to be money times and then material. But in this case, we have to see they didn't actually tell us the amount. So we are going to find the minimum area that will minimize our cost. So you have to see, hidden question is, I cannot find the cost, but if I find the minimum area, minimum surface area, that will minimize my cost here to find it. So we are going to set our output is going to be the minimum area of a cylinder. Okay, and then what do we need to set now? Input then. Since it's a cylinder, do we use X or R? We are going to use R as a radius of can. So I'm going to set that as R, and then we'll try to find minimum area of a cylinder. So what can I do? If I want to find the area of a cylinder, I need to open the cylinder, and the area of the surface will be open this way. Everybody see it? Why is shaped this one? Top part, bottom part, and then around the middle part. So I want to find the area. Only information I know is this is R. Then what is the area of the top part? That's pi r square, which is the same as the bottom part, pi r square. Then what's the area of a middle rectangle? Well, that length here is going to be same as my circumference of the circle. So that's going to be 2 pi r. And then what's this? I don't know. So I have to use this one as h, as a height. Then that is going to be area 2 pi r h. So the function that I want to find is area of a cylinder. Input is r, so you can only use r in here. So look at, I have a 2 pi r square, adding it, plus 2 pi r h. But when you look at here, this is a function, but I cannot use two variables. We can use only one variable as r, but I have h. So how can I get rid of the h? H is going to be come from my height, but do I know that volume? Yes. So what is the volume of a cylinder when the radius is r and height is h? So this is r, and then height is h. Then always the volume is base times height. So what is the base? Base is going to be pi r square, and what is the height? H. So I got the volume is pi r square h, but they already gave me. What is that? That's 1 liter. Exactly. So what I'm going to do is I'm going to replace the h value in terms of x. That's I'm going to approach soon. But look at here. I cannot still use this one yet because my units are different. This is a liter, but radius is going to be probably centimeter. This one we have to use a centimeter. Why? Because 1 liter different unit we cannot use it, but we can change that into same unit. 1 liter is the same as 1,000 square cube centimeters. So here shows that pi r square h is 1,000. So if I solve for h, I get 1,000 over pi r square. So if I replace this one, substituting to this h, then I can rewrite all my equation in terms of x and r. So this will be, let me continue. This will be by plugging, let me put it a bit better. By plugging h here, then that's going to be 2 pi r square plus 2 pi r 1,000 over pi r square. Then you see this cancel out, this one cancel out, so it turned out to be simple 2 pi r square plus 2,000 over r. That's what I get as my function. That's why you want to put it as a function. So when I look at this one, I cannot have more than one variable. So if it's input r, you have to change everything in terms of r right here. Okay, no two variables. So now we got the first derivative, regular function, which is we are going to use this function. And what is this? That is a surface area. So if I want to minimize, I need to take a derivative. So let me take a derivative here. A derivative will be 4 pi r plus minus 2,000 over r square. I did everything mentally. So 4 pi r plus minus, because that's r to negative 1, minus 2,000 over r square. I want to find critical point, so equal to 0. Then let's set up 4 pi r is equal to 2,000 over 4 pi r is equal to 2,000 over r square. We can do cross multiply, gives me r cubed is 2,000 over 4 pi. Multiply and divide by 4 pi. So r is going to be cube root of 2,000 over 4 pi. That's the answer. Okay. Yeah. And from here, Now we need to punch in that number. So what will be 2000 divided by 4 pi to the 1/3 power gives me 5.4192 as my radius centimeter. Okay, then from here we need to talk about a little bit more. So Yona, how can you verify that this is a minimum? Because I didn't verify yet, right? So how do I verify this is minimum? Well, then you need to see that that's the first derivative graph. When you plug in 5.4192, that will make 0. So we need to plug in 5. I'm going to plug in 5 quickly, and it's going to be 5 into, I'm doing test point 5 here, and then I'm going to plug in 6 here into here so that I can check my sign. So 4 pi times 5 minus 2000 and r squared. Then that gives me negative 17.16, and I'm gonna do the same thing with plug in 6. So if you don't see the graph like how I explained, then you just from the critical point, plug in number 1 down, number 1 bigger. Then I got negative 17.16. When I plug in 6, I got 19.84. That already shows that my graph is gonna look like this way, right? Negative, that's positive of a first derivative graph. So this number is going to be decreasing, increasing. So I can say that that's local minimum. I need to see verifying part on your paper too. So always try to plug in and then verify if you cannot find the graph. So that's now minimum. Then answer, we did not answer yet because R value is this. When R is 5.4192, then while the surface area, all we need to do is plug in here. So let me use that number. If you put in this number, that will be perfect answer. And if you put in this one, it's gonna give me some rounding answer, right? So 2 pi, and I will just use 5.4192. Okay, then I got as 553.58 as a surface area, so it's going to be square centimeters. Okay, so what does this mean? I want you to say 5.4. 5.4 is about this much. 5.4. Yeah, and when you have a radius about this much, so it's going to be this much is a diameter, and then if you about this much can when you make it, you want to make radius as 5.4. Then if you plug in this number to your R, you're gonna get H value. I believe that with my experience, probably twice bigger. So let me find the H value for you just for fun. So 1000 divided by pi and 5.4192 square. Yeah, exactly what I guess. So I got 10.8387. So let me draw it. 5 centimeters is about this much. So doubling it. So my radius is about 5.4142. And then as you see, my height is same length as your diameter, right? That's a 10.84. At that time, you will have you will have biggest volume, which is 1 meter, with the smallest surface area. That's you're gonna spend about this much. Okay. All right. It's a little bit confusing, right? So I wanna actually plug in and then see that what happened when I have 553.4142. I got area as a 553.58. Just for fun, I want to put 2 centimeter. What if it's 2 centimeter? Half, not even half. It's going to be about 2 centimeter. So I'm going to make it this. Then your surface area is going to be changed, although your volume is the same. So I'm going to plug in 2 in here into my surface area. And what will give me as a minimum surface? So okay, so if I plug in 2, I get actually 1025, 13. Okay, I want you to see the differences. Do you see that if I have a radius 5.42, you only need 553 square feet, basically, rounding. If you use 2 centimeter, then how much you have to use for surface? 1025. Do you see that? About twice more. About twice more. That means that as your factory owner or you are the CEO, you don't want to see that, right? Because that's totally wasting money of the same amount that you can hold it. So that's why it's very important optimizing in the company, because you can save twice amount of the money of your material. So that's what we are doing. But Young, this is still hard. Then I will show you with the decimals, okay? Okay, class, so let's look at decimals. As you see the function of 2 pi x squared plus 2000 over x. Young, how do I know my answer is correct? Because that's the point you're looking for, right? Before the calculus, we cannot find any other function besides a quadratic, but now you guys can. So I punched in and then I just click that one. Do you guys see that? 5.419 gives me area 553. If it matches, then yes, you got the correct answer. That's how you can check. Then earlier we also checked with the 2, right? How much the surface area will be when the input is a 2. So if I plug in 2 here, about 2, then do you see 1023? You see, I don't know if you saw it. So I clicked it around here, then that gives me same number about up here. So also, so you see, how do I know? Depending on if you get even bigger radius, that means that your surface area gets also worse again. So what is the ideal size of the package? Usually, as you see, kind of this size about the same. Yeah. So when you see this one is the same, that will usually minimize the surface area. Pretty cool, right? So the answer is going to be, when R value is 5.4192, also you can write it this one, and those ones you should be able to do without calculator up to here. Then you will get minimum surface area 553. But think about, that's only this much, right? 10 centimeter by 10 centimeter. So that's this much. That is 1 liter. So imagine 1 liter. How much is 1 liter? About 3 over this one is probably 1 liter, right? So think about that of the amount. Okay, so we will do one in-class activities, similar question, and then I want you to compare the answer with me. Okay, so compare the answer with me. How did it go? So same thing, input, output as a surface area. Then my surface area, if I simplify in terms of everything R, as you see input is R, we cannot use H there. So forced to change in terms of R gave me this function. So I took the derivative, and then I set equal to 0 to get critical point. So my R value turned out to be 4.3013. Okay, so when I plug in this R value, gave me my surface area as 348.734. Then again, Young, I want to check the answer. Is this really correct answer? So you can always go back to here, but I actually need to see all your work as well. If you look at, do you see that 4.301, 348.734? Exactly. So if you graph, that's what you got. So let's conclude that earlier, as mentioned, if we have those 3 different kinds of glasses, what do you think that actually give me the least amount of the surface area? First one, second one, or third one? Actually, this case, this one, whenever you have a right proportion of this one will give me the smallest surface area, although they hold the same. Then when you see here, I want you to also see that here to here, if you reducing your radius in half, then as you earlier saw, your cost of making surface area could be twice more. So if you see the can, what is it, Coca-Cola can? I don't think I have any can. Let me know. Okay, this is not a can that I tried to show you, but do you guys remember those Coca-Cola can? Why do they make that shape? That one had a mathematics too, because if you make this one, that will actually cost more. If you make it this size, it's definitely gonna, with that size, it's gonna cost less. That's why they made a Coca-Cola can shape as a, that shape exactly, because they calculated all these kind of a part. But another thing I want to talk about is volume. Earlier we had a 1 liter. Now I have a half liter, exactly half amount of the volume. Earlier we had a radius 5.3 will be maximum. I remember about 5.3. Okay, just say that. So when I was thinking, oh, my volume is gonna be half, then did you think that my radius has to be also half, like 2.5-ish instead of 4.3? Because when I saw this one, I was more guessing, oh, my answer, I want to see about 2.5, but I saw 4.3. I was like, whoa, what happened? Because I didn't think that it's going to be very close to 5.3 or the 5 point number we got earlier one. Why is that? Think about this way. I have area as 1. If I'm going to increase it twice, then the side is 1, then my area is 1. But if I'm doubling it, my length, then it becomes, area becomes 4. If you double your side, then your volume becomes actually 8 times more, because area is 4 times, volume is going to be 8 times more. So I want you to think about this time why I didn't get half of the earlier one, I feel 5.3 or 5.103. Sorry if I'm messing up. But why it wasn't 2 point something? Why is it 4.3? Because now you have half amount. That means your length will be only 3/4 reduced, basically. I want you to feel that if your length is increasing twice, and then your area increases 4 times, your volume increases 8 times. That's what relationship is. This one is a centimeter to the volume relationship. That's why they are going to be not half of the radius, only quarter amount will be reduced. Just think about that. If you're not getting it, just come visit me. So that's it in class activities, and let's do dessert. Okay, so let's start the dessert. Today's the most highlight part, and it's gonna be one of the most difficult ones. So listen, and then let's do next activities and by yourself so that you can make it yours. So a man launches his boat point A on the bank of this District River. And 3 kilometers wide, 3 kilometers wide. This is a 3 kilometers wide. And then he wants to reach point B from point A. And point B is 9 kilometers downstream on the opposite side of the bank. So this length is 9 kilometers. And if he can row a boat 4 kilometers per hour, and then he can run 8 kilometers per hour, where should he land to reach B as soon as possible? So what's going on is he wants to cross the river. Then I want to see that how he can reach there. So as you see, there are 3 cases. This question, I have to really squeeze the spot. So I have 3 cases. One case is you can just go straight like this. That's the first case. Second case is you can go this way. And then third case will be what we were looking for. Let's just run over here and then take a boat to this way. So there are 3 cases. Then let's try to read the question again. What do we want to find? Where should he land to reach B as soon as possible? So you have to read the question. Are we looking for distance? Are we going for rate or time? What I like to find here, I want to where should he be to reach B as soon as possible. Do you see that? This is a little bit tricky. So my output is as soon as possible. What does that mean? That's going to be shortest time. Shortest time. When? When I landing here. So I can set this distance as x. This distance as x. Right? Then before we get into green color, we want to see that what have to break into those three cases. Let me explain to you with second case first. So what is the time? Time distance is equal to RT. Then time is the same as the distance over R. So in order to find how long it takes to run 9 kilometers and crossing 3 kilometers, we can see that the time is going to be input as time is going to be the distance is 9 kilometer over what was his rate of running. He can run about 8 miles per hour, and then he can roll about 4 miles per hour. So time that he run here is 9 kilometers over 8, plus now he has to go 3 kilometers with speed 4. So if I add this one, that's going to be 15 over 8. That gives me about 1.875 hours to get there. Then let's look at first case. That's we go straight here. That means you just row your boat all the way. So how do we find this distance? We have to use a Pythagorean theorem, right? So 9 kilometers square, 3 kilometers square. So that's going to be 81 plus 9 is 90. So I'm gonna take square root of 90. Gives me the distance of as 9.848. So I got square root of 90. So this length is square root of 90, which is about 9.4868. So if I want to find what is the time it takes to cross only using rowboat, that's going to be square root of 90 divided by speed was, boat speed is 4. Then it gives me 2.37 hours. It's a lot longer, right? A lot longer. So if you go this one, definitely I'm not gonna go that way because this is gonna be shorter than what you thought, right? This takes 1.875. This one takes 2.37 hours. Then can we find, is there any point you just landing so that I can get to there? So I set that one as x. Then watch carefully. What is this length? That's going to be 9 minus x. That's going to be 9 minus x. Then let's try to calculate this part of the time it takes. So time takes the running on along the water is gonna be total x amount over what's the time it takes. That is going the speed is going to be 8 miles per hour plus, because time is a distance over r, and then now what is this distance? What is this distance? We have to find that distance. That's going to be our Pythagorean theorem. So 9 minus x squared plus 3 squared has to be this distance squared. Therefore, that distance will be square root of 9 minus x squared plus 9 over the speed of crossing the water, definitely slower than the land, which is 4. Now, do you guys recall that? We learned how to take a derivative of this one, right? So if you look at the previous part, and you will see this one answer, you will see the answer here. Let me pull it if I can find the answer. So class, I haven't started the question yet, but if you actually take a derivative, which we learn about 4.2, if you take a derivative set equal to 0 and then solve for x, then you will get your x value as a 7.268. What does that mean? That means when you run about 7.268, when you have about 1.732 left, then that will actually take about 1.775 hours. So you see that which one will actually get there the fastest time, because definitely not this, definitely not this. Then we have to find where should I start taking boat. And after you run about 7.268 meters, then you can row the boat to the other side. Will give me the minimum time, which is 1.775, about 1 hour 45 minutes. But Younga, why you didn't show me this one? Well, let's approach this one how I want to do. So we've set input as an x, but x this time was a distance from where you're starting to where you're going to take off. But this time I'm going to switch my graph of x to a little bit off, which means not off, but differently. So still my question is same. I'm crossing the river and try to get there. And this time, instead of setting x here, I want to set x here. Why? I want you to see little differences. If this is x, then that's going to be 9 minus x. And if I want to have this length as a 3, do you see that the diagonal will be only x squared plus 9? You see that your equation becomes a lot easier. So what is the distance of the water to where you're going to take off? That's 9 minus x. Then what's the distance you are going to take a boat? That's going to be square root of x squared plus 9 from Pythagorean theorem. Then let's try to find the function as a time. So time input, output is a x, but I switch my x from this x to other one. Basically same. If I get the x, subtract the x, I will get the same answer. So time means distance over rate. So what is this distance? Square root of x squared plus 9 over, what's the rate is 4, plus you have to walk this much or run this much with your rate 8. Okay. Basically, these two are same question. I just set the x other way around. Why did I do that? Because it will make it easier to take a derivative. So let's take a derivative. I hope they have room. I'm not sure, so I have to squeeze it a lot. So if I take a derivative of this one, 1 over 2, and then I have that 1 over 4 before, and then 1 over 2 square root of x squared plus 9, and chain rule 2x, plus take a derivative that will be negative 1/8. Do you see as a 9 over 8 minus 1/8 x, right? So you can change to linear and then take a derivative. So I get that. That has to be equal to 0, right? So if I continue, it's going to be 2x over a square root of x squared plus 9 has to be 1/8. Then can I multiply a both sides? So those are gone. Now I have 2x over square root of x squared plus 9 equals 1. So let's do cross multiply. That gives me 2x is equal to square root of x squared plus 9. Square both sides. That gives me 4x squared is x squared plus 9. And that makes it 3x squared is equal to 9. X is equal to plus minus square root of 3. But it has to be positive, so I'm going to use only square root of 3, which is 2.235, 1.732. So square root of 3 is about 1.732. So now let's check. If I set this one as x and I got that value as 1.732. So subtract from 9, then do you see that I get exactly same as a 7.268? But, Yana, why did you approach it that way? Well, earlier when you do 4.2, that's how your textbook approach. For me, I will approach it this way. And you see that my derivative is so much better, so much easier. And Yana, how do you check that this is your minimum? Same thing. You have your point 7.26. Now you can plug in here 7, plug in here 8, and if you graph it, it's going to turn out this way. Then my graph is going to be concave up. So original function is concave up. So I can indicate that this value is going to be my local minimum. Okay. Then how you check? Same thing. You just punch into decimals and Let's see if I can see that value. If I punch into decimal, do you see 7.268? And then that's the value I found. So did we finish answering? Did we finish answering? No, I didn't answer yet. But if I plug in this number, either way, so this case I got x as a square root of 3, then you have to plug in your number to here to get the answer. And if you use your function set x is this side, the derivative is going to be a little bit more challenged than the other one, but you see that you get the same answer. Now if you plug in 1.732, what you're gonna get as your answer? Same answer is 1.775. So I minimize the time it takes after you walk 7.2 meters and then row the boat. Rest of them will give you the minimum time to get there. It's pretty interesting, right? So I want you to understand, and then your answer will be 1.775 hours as a minimum time, as the shortest time. I hope you can see. Okay, so there's another question, same one, but set as different number. So I want you to be careful. But x, just to try to see that where you're defining it. It's hard to describe, but if you graph it, I will understand. So you see that depending on where you set x, the life will be so much easier or harder. Okay, good luck. Okay, how's it going, class? So as I said, you guys will prepare everything of last chapter 1 to 3 to do these questions, and I want you to feel that how beautiful it is, how smart you are, how wise you are to figure it out. And I love calculus because it comes everything of math you learn in your life, you put in here, and then now it makes sense why you learned this, right? So that's why for me optimization is a very powerful question. You basically prepare 12 years to do questions like this. So good job. So compare the answer, input x, and we want to minimize the time. Always the hint is the shortest, the fastest possible, and those are the words. So minimum time, then time we write as a distance over rate. So I found all the distance and then all the rate, and then I just put it together, distance over rate plus the distance over rate, so that I can find the time of together going two different segment. Then I get x as a 7.5193. Earlier, sorry, I made a mistake as a kilometers, but since the miles per hour, all my unit has to be miles. So after you walking 7.5 above, taking a boat will give you the minimum time. Oh, I didn't find the minimum time. So if you plug in, but this time I change my x to this side, then you see my distance of a rowing boat is going to be this, and then your running will be 10 minus x. So as you see, distance over speed was 4, distance over speed was 9, and I took the derivative of this one instead of the other one because you experienced that that was a lot harder. You can do that way too, nothing wrong with me. Then I found it gives me 2.481. So I subtract from 10, it gives me 7.519. But we need to see how long it takes. So I'm going to plug in, and then you also need to plug in and tell me the time, because that's what we want to figure it out. And as earlier I showed you, this way will take longer, although this will be shortest distance. So if I plug in, and I got 2.23 hours. So it's gonna take longer than earlier one because my distance is a little bit longer too. So when you walk 7.5 and then rowing the boat, the total trip will make about 2.23 hours. 2.23 hours. Okay. So this is it, and then we are having a part 2. So part 2 will be, I'm going to set up to here, and then you guys are gonna do derivative and then upload it. So with next 4 questions, keep playing with me, keep playing math with me. Then when you do more, you will get better. Good job.